All right, let's get right into it. We've all looked up at the night sky and wondered how all those worlds out there came to be. And for a long, long time, we thought we had the story pretty much figured out. But what if that whole story was wrong? Right now, our understanding of how planets are born is going through a massive shakeup, and we're going to look at the incredible new evidence that's completely rewriting the cosmic rulebook. You know the picture, right? The one you see in all the textbooks. A young star surrounded by this perfectly flat, calm disk of gas and dust, kind of like a giant vinyl record spinning in space. We imagine this serene little cosmic construction zone where planets formed slowly, methodically, over millions and millions of years. Well, it's time to throw that picture right out the window, because thanks to incredible new tools like the ALMA telescope and the James Webb Space Telescope, that old story is getting torn to shreds. The reality they're showing us isn't one of calm, serene order. It's a story of cosmic chaos. It's faster, it's messier, and honestly, it's way more surprising than we ever imagined. So to really get why this is all such a big deal, we need a quick refresher on the old rulebook. Basically, astronomers had two main recipes for how you build a planet from scratch. Think of them as the snowball versus the snowplow. The first one, core accretion, is the snowball. Tiny dust grains bump into each other and stick, and they just keep sticking, growing bigger and bigger, rolling through the disk until you have a solid core that starts pulling in gas. Then you've got gravitational instability. That's the snowplow. This one is way more dramatic. The disk itself gets so heavy that huge chunks of it just collapse under their own weight. Bam! A whole planet forms in a flash. Now, why do we need two theories? Well, that snowball method is pretty good for planets close to their star, but it's slow. It's way too slow to explain how you get giant planets, like our own Jupiter, way out in the cosmic suburbs. There just isn't enough time. The snowplow method, on the other hand, is like a cosmic fast pass. It gives us a way to build those massive, distant worlds in a hurry. And this whole idea of speed, well, that's where our story really kicks into high gear. Let's talk about the first major crack in that old, orderly model. And it has everything to do with the clock. That slow, peaceful process we pictured? Yeah, it turns out it's more like an all-out cosmic sprint right from the starting line. And it all started with this really simple question from a Yale researcher, Chang Han-si. You see, when planets form, they carve out these huge rings and gaps in their home disks. And he just wondered, how early does that actually start? We'd always seen them in older, more mature disks, but his team decided to look at the absolute babies, the youngest planetary nurseries they could find. And what they found was absolutely stunning. Look at this. The classic timeline for planet formation was supposed to be somewhere between 1 and 10 million years. But the ALMA telescope started seeing these clear, telltale signs of planets in disks that were only around 300,000 years old. That's not just a minor adjustment, that's a radical compression of the entire timeline. The implication here is just huge. If planets are already carving out their space this early, that slow and steady snowball model simply doesn't have enough time to work. All of a sudden, that faster, more chaotic snowplow idea starts looking a whole lot more attractive, doesn't it? But hold on. Because it's not just the timing that's getting blown up. The James Webb Space Telescope has found a baffling chemical mystery in a young star system. And it looks like a key ingredient we thought was essential for life is completely missing. So just think for a second. If you were going to build an Earth-like planet, what's on your cosmic shopping list? What are the absolute must-have ingredients? You've got your basics, of course, gas, dust, rocky silicates. But the one we always assume is there, especially if we're hoping for life, is water. Our standard models have always predicted that the warm inner part of a disk should be full of water vapor. This is where the story takes a really sharp turn. JWST pointed its powerful eye at a young star called XUE10, fully expecting to find that familiar signature of water. But what it found was basically nothing. Check this out. The typical model on the left says the inner disk should be dominated by water vapor, but what JWST actually found at star XU10 is an inner disk that's absolutely swimming in carbon dioxide. And the water signal? It's so weak it's barely even there. This isn't just a small difference. It suggests a completely different chemical recipe for the planets forming in that system. As the lead researcher, Jenny Frediani, said, the lack of water is dramatic. And it is. It totally shatters our expectation that water is just this common, readily available ingredient for any rocky worlds forming in the right spot. So, what in the world is going on? Well, the leading theory is that this whole star forming region is getting blasted by intense ultraviolet radiation from massive nearby stars. This radiation acts like a cosmic demolition crew, breaking apart the more fragile water molecules while leaving the tougher CO2 molecules intact. This could mean some planets are born in a completely different kind of chemical soup than our own. So we've got planets forming way faster, and sometimes with a very different chemical recipe. But there's one more pillar of that old model that's about to come crashing down: the idea that these cosmic nurseries are perfectly flat. Let's go back to that old mental image one last time. The perfect, pristine, flat as a pancake final record, spinning away with beautiful, orderly grooves being carved into it. It's a vision of beautiful geometric perfection. But reality, it turns out, is a lot more crooked. New, super detailed observations from ALMA are showing us that many of these disks aren't flat at all. They've got these subtle warps and twists, with different parts of the disk actually tilted a few degrees from each other. As Dr. Andrew Winter points out, this is a huge change in how we see things. A few degrees might not sound like much, but it implies a much more chaotic, much more dynamic environment. These warps could be caused by the gravitational tug of another star, or even just the messy flow of gas. Either way, it has huge consequences for how planets form and where they end up. So what does this all mean when you put it together? The incredible speed, the weird chemistry, the warped structure, we're looking at a completely new blueprint for how the universe builds planets. So let's lay out the new rules. First, planet formation is fast, kicking off in what's basically the blink of a cosmic eye. Second, it's more chaotic. These disks are warped and messy, not pristine and flat. Third, the ingredients are chemically diverse. Some systems are starting out rich in CO2, not water. And all of this tells us there are multiple pathways to build a planet. That rapid snowplow method is definitely a vital part of the story. You know, what's so exciting about all this is that it's a perfect example of science in action. We build these incredible new tools like ALMA and JWST, and they let us peel back layers of the universe we could never see before. And those old textbook pictures, they're not being replaced with final answers, they're being replaced with deeper and way more fascinating questions. And that leads us to this final massive question. If the process of building planets is so much faster, so much messier, and so much more chemically strange than we ever knew, what does that mean for the search for another Earth? It forces us to ask, is a solar system like our own with its specific chemistry and its tidy arrangement the standard model? Or are we the cosmic exception?